Imagine looking up at the night sky and realizing that every star you see is already unreachable. Not because we lack technology, not because we lack ambition, but because the window to ever reach them has quietly closed. Music interstellar travel feels like humanity's destiny. The next great leap, but according to physics and biology, that future may already be impossible. Most people assume interstellar travel is just a technological problem. Faster engines, better fuel, enough time, and we'll solve it. After all, we went from the first airplane to the moon in one lifetime. Surely the stars are just farther away. That assumption is wrong. The real problem isn't distance, it isn't speed, it's time. And what time does to fragile human bodies in an environment they were never designed to survive? By the time we fully understood this, it was already too late. Interstellar space is not empty, it is hostile. On Earth, life survives only because of a precise balance: gravity, atmosphere, magnetic fields, and constant energy from the sunday. Remove those protections, and the human body begins to fail. Slowly at first, then irreversibly. The closest star system, Proxima Centauri, is 4.24 light years away. Even at speeds far beyond anything we can realistically build, the journey would take decades, not days, not months, decades. And distance is only the surface level problem, because time is the true enemy. In deep space, radiation becomes relentless. On Earth, our atmosphere and magnetic field block nearly all of it. In interstellar space, there is no shield. High energy particles slam into the body non-stop, damaging DNA, brain tissue, and organs at the cellular level. Over long periods, the damage outpaces the body's ability to repair itself. But radiation is only the human body is all isolation. Humans are not built for lifelong confinement. Decades inside a sealed spacecraft with no rescue, no escape, and no margin for error would degrade mental health, decision-making, and social stability. This isn't theory. We already see it in much shorter missions. Even if biology and psychology could somehow hold, physics still delivers the final blow. Entropy. Every machine degrades. Materials fatigue. Electronics fail. No spacecraft can remain perfectly functional for decades without repair, infrastructure, or resupply. One critical failure, years from help, ends everything. Over enough time, failure becomes statistically inevitable. This is where the equation breaks. Interstellar travel demands near-perfect systems operating longer than any complex machine has ever survived. It also demands human bodies remain stable far beyond their biological limits. The math doesn't work. Even reaching another star offers no salvation. Nearby stars are often more violent than our Sunday planets, are bombarded by radiation, stripped of atmospheres, or locked in extreme environments. Earth is not typical, it is rare. We are adapted to one planet, one star, one narrow set of conditions. The farther we move from that baseline, the more artificial support we need. Eventually, the support system becomes the environment, and the environment becomes the limit. This is why the problem isn't technology, it's physics, biology, time. For a brief moment, interstellar travel looked possible, in theory. But reality includes decay, aging, error accumulation, and irreversible change. Once those factors are fully accounted for, the conclusion becomes unavoidable. Interstellar travel isn't just difficult, it isn't just dangerous. It is fundamentally incompatible with being human. The stars were never waiting for us. We were already too late.